Let's continue with number 4. What is the equivalent resistance here? So the first thing I'm going to do is I'm going to redraw the circuit, and I can combine these two that were in series. So this is my original circuit right here. I'll just draw it again. You might not need to. That's the original circuit here. And then I'm going to combine these two in series. So now they become 1. I still have the 1 down here. And 4 and 10 were in series. When they're in series, their equivalent resistance, you just add. So this one is now 14. And this is still 6, and this is still 7. And now we notice that these two are in parallel. So we simplify them again. And I'm just using shorthand here, so I'm looking at this one. I'll just call it R again. It doesn't matter too much since we're not having to work backwards in this one. So this R is these two in parallel. When they're in parallel, you have to use 1 over R is going to equal 1 over 14 plus 1 over 7. Because we simplified these two that were in parallel here to get this one. So I'll call it RP. That was R that was in parallel. This was RS. 14 was in series from these two. So when we do this right here, we're going to get RP. When you do the math, you're going to get RP equals 14 over 3. Because when you do this, you get 3 over 14. Then you flip it, you get 14 over 3. And then we have to simplify one more time because now these two are in series. So we have one final circuit where this is RS now, or R equivalent, where we had these two in series. So that means these two are just going to add. So R equivalent is going to be 6 plus 14 over 3. And when you put that in the calculator, you'll get 10.7. Number 5. 3 resistors connected in parallel have individual values of 4, 6, and 10. So it actually tells you that they're in parallel, but it didn't even need to tell you that because you could see it from the picture. And then this is connected in series with a 12-volt battery and a 2 ohm resistor. So what's the current in this resistor right here? So this is one where we have to simplify and then work backwards, because if we're trying to find the current in here, we don't know the voltage here. It's not the full 12 volts because there's some volts that are going to be here. So we can't just look at it and just use Ohm's law like the other problem that we did, number 3. So for this one, we really have to simplify and then work backwards. So because I like to do it from left to right, I'll go ahead and draw the original circuit one more time. And then I'm going to simplify these 3 that were in parallel. So if I call this R1, R2, R3, and then R4 over here, then I'm going to simplify the 3 that were in parallel. And I'm going to call it R123. And that's still R4 right here. So when they're in parallel, you have to use the 1 over equation. So 1 over R123 equals 1 over R1 plus 1 over R2 plus 1 over R3. So plug in the 10, the 6, and the 4 in there. And when you solve for R123, you will get, I'll let you put it in your calculator, you'll get 60 over 31. I'm leaving it as fractions so that I'm not rounding too early. And now we have 2 in series. So I'm going to simplify them again to get my equivalent resistor, R equivalent, and our equivalent came from these two in series, so R123 plus R4. And that's going to be, I don't have a number for it, but I'll get one real quick. That's going to be, sorry about that, 60 divided by 31, which gives us 1.94, and then plus 2 gives us 3.94. So now we have to work backwards. We're trying to find the current in resistor 1 here. So we know the voltage here is 12 volts. So we can find the current through this circuit. We can use Ohm's law, and we can say the current through this circuit here is going to be V over R, which is going to be 12 over 3.94. And that's going to be 3.05. And then we go backwards, we go to this circuit and we say, okay, these two resistors were in series to get to this one. When resistors are in series, we know that the current through these two resistors must be the same as through the equivalent resistor. So now for R123, we know that the current through 123 is going to be the same one that we just found. And now since we have the resistor 123, which was 1.94 ohms, then now we can find the voltage across 123 using Ohm's law, I123 times R123. So multiply 3.05 times 1.94, and we're going to get 5.91 volts. So that's the voltage across this resistor, and now we go back a step, and these three were in parallel to get to this one. When resistors are in parallel, we know that the voltage across each resistor is the same as the equivalent. So we know that the voltage across 1 is the same as the voltage across 123. It's going to be 5.91 volts. We know the resistor 1 is 10 ohms. So now we can use Ohm's law one last time. I1, the current through this one, is delta V1 over R1. So 5.9 divided by 10, and that's where we get the 0.59 from.